Hello everyone. In this video, we are going to see the subject name control systems. We are going to see introduction of control system and its types. And this video. What does mean by control system? When a number of elements are connected in a sequence to perform a specific function, then it is called a system. So whenever we want to have sequence of functions to be performed, then we call that as a system. But what does mean by control system means? When the output quantity can be controlled or varied by varying the input quantity, the system can be called as a control system. This is a proper definition of the term called control system. Now, we have two things. One is our input quantity that is controlling the output quantity, and output quantity which is being controlled. So, the output quantity is called as controlled variable or response, whereas the input quantity is called as command signal or execution. You can see a simple example of a term called control system. We have a digital camera, taking a picture, that is the input. We process the input and we get the output. This is a very simple example of a control system. Next, we see the types of control systems. Basically, control system is classified into two types. They are open loop system and closed loop system. Now we'll see one by one. What does mean by open loop system? We have input, we have a process, we have output. This simple type of system is called as open loop system. These are some of the characteristics of your open loop system. When we change the input, automatically output will be changed, and when the output quantity has no effect on the input quantity. Depends upon the output, your input will not be changing, but depends upon the input, output will change. There is no reverse action. Changes in the output cannot be corrected automatically. There should be manual intervention to change the output, because there is no feedback mechanism in open loop system. A simple example of open loop system you can see here. We have a toaster machine. The output of this toaster machine, that is the toasted output of the bread. Now the system does not reject any changes if the heat is more or the heat is less, the bread is toasted correctly or not correctly. That is not corrected by the system automatically. Manual intervention is needed. Such type of systems are called as open loop systems. We have some advantages for this open loop system. It's very simple and economical to build, easier to construct, and the output will be stable. It will not get affected because of environmental disturbance. Obviously, we have some disadvantages too. Output may be inaccurate, the output is not unreliable, and as I said earlier, changes due to external disturbances are not corrected automatically. These are some of the drawbacks of your open loop system. So how can you overcome those drawbacks? By using our closed loop system. So in closed loop system, you can see here, we have a controller, we have a system, and obviously the most important part of closed loop system is we have a feedback mechanism. Our closed loop system, changes in output affects the input. Previously in open loop system, we said output change will not affect the input, but here changes in output obviously affects the input. So the closed loop system are also called as automatic control system. So changes in output can be corrected automatically. Manual intervention is not needed over here because we have a feedback mechanism. Simple example of your closed loop system is our AC machine, where we set the room temperature and they will have a sensor to sense the room temperature. If the room temperature is not equal to the set temperature, your room temperature will be reduced further. That will be equal to the set temperature. Once you set, your job is completed. The machine will take care of making your room temperature to be equal to the set temperature. Because of feedback mechanism, we are doing these changes. So we have some advantages for this closed loop system. It is accurate, it is reliable, and is less affected by noise, and it is very fast in work. And as I said earlier, external disturbances can be corrected automatically. We have some drawbacks also. Because of this automatic correction and feedback mechanism, your system will be more complex and costly. And since we have feedback, your gain will be reduced. Open loop systems are highly stable systems, whereas closed loop systems are having a problem for stability. So we should have a special mechanism for this maintenance of stability in closed loop systems. Simply, we have many applications for control systems, starting from your home automation to medicines field, robotic field, agriculture field, automobile field, and even in any system, any day-to-day life activities, you can see control systems. So that's all in this video. Thank you all. We'll meet again in next video.